Welcome back, everyone, to another deep dive. And this time, we're going to be talking about high-speed networking in Proxmox.
All right.
So you might be considering doing your own 100 GBE upgrade, or you're just curious about what it takes to get this type of speed working.
Yeah, definitely. There's a lot to consider.
So luckily, we have a detailed case study where someone documented their whole journey of getting 100 GBE working in Proxmox.
That's great because I think a lot of people are interested in this topic, but there's not really a lot of information out there.
Yeah, and it can be a bit overwhelming because, you think you build the perfect 100 gigabit network, and then you find out you only get a tenth of the speed.
Right? Like, where you even start troubleshooting that?
Yeah, exactly. And that's exactly what happened to the author of this case study, and he's going to help us understand what can go wrong.
And more importantly, how to fix it.
So our case study author started with what seemed like an ideal setup. He had dual 100 GBE NICs and a high-end microtic switch, but right away he ran into problems.
Right, because it's not just about having a fast NIC, there's a whole chain of components that have to work together.
Yeah, that's what I've learned too.
Like virtualization itself introduces overhead just by the nature of how it works.
Oh, really?
Yeah, like with the Vertio drivers and CPU queues and memory bandwidth limitations, all these things can actually affect the performance.
So even with a 100 GBE connection, you could still have these bottlenecks.
Exactly. It's like having a huge pipe but a tiny faucet.
I see. So what kind of speeds was he actually getting?
Initially, he was only getting around 10 to 13 gigabits per VM.
Wow, so that's nowhere near 100.
Yeah, it's a big difference.
Okay, so the first hurdle was virtualization overhead. What was the next bottleneck?
Well, it turned out that the CPU was a major bottleneck.
Oh, really? I wouldn't have thought of that.
Yeah, because processing all that data at 100 gigabit speeds is a lot of work for the CPU.
Makes sense.
In the case study, we see that CPU utilization was reaching like 80 to 90% when they were testing.
So even with a super fast NIC, if your CPU can't keep up, it's going to hold everything back.
Exactly.
Okay, so we got virtualization overhead and CPU limitations. How did they start to improve the performance?
Well, the turning point was something called multiqueue networking.
Multiqueue networking. I haven't heard of that.
It's basically a way to allow the network traffic to be processed across multiple CPU cores.
So instead of just using one core, you can use multiple.
Right. It's like having multiple lanes on a highway instead of just one.
I like that analogy. So what kind of improvement did they see?
Enabling multiqueue in Proxmox increased the performance from those 10 to 13 gigabits per VM all the way up to 48 gigabits.
Wow, that's a huge improvement.
Yeah, it's a big difference.
So it seems like multi-queue is essential for anyone who's serious about 100 GBE in Proxmox.
Yeah, I would say so.
But I'm guessing there were still more things they had to optimize.
Oh, yeah, there's still more to come.
Like what?
Well, the next challenge involves something called NUMA.
NUMA.
Yeah, it stands for non-uniform memory access.
NUMA. That sounds complicated.
It can be, but basically think of it like having different neighborhoods in your computer's memory.
Different neighborhoods.
Yeah.
Okay, I think I can visualize that.
So if data has to travel between these different neighborhoods, it takes longer.
So the goal is to keep everything in the same neighborhood.
Right.
So how did they address this in Proxmox?
Well, the author found that just enabling NUMA awareness in Proxmox itself didn't make a big difference.
Oh, really? So what did they do?
They had to carefully assign VMs to specific CPU cores and memory within the same NUMA node.
Ah, so it's all about optimizing the placement of resources.
Exactly, and it gets pretty granular.
I bet. So did they use SR-IOV?
They looked into it, but it wasn't the right fit for them.
What is SR-IOV?
SR-IOV stands for Single Root I/O Virtualization, and it's a way to give VMs direct access to the network hardware.
So it bypasses the Proxmox virtual network stack.
Right.
So it's like a shortcut.
Yeah, you could say that, but it comes with some trade-offs.
Like what?
It can make things like live migration more difficult.
I see. So it's a trade-off between performance and flexibility.
Exactly.
Okay. So we've covered multi-queue NUMA optimization and SR-IOV. What else do they try?
They also experimented with jumbo frames and network offloading features.
And did those make a big difference?
Not as much as the other optimizations.
Okay. So after all this tuning, did they finally reach 100 GBE?
Well, we'll have to wait and see.
Okay. Good suspense.
We'll reveal the final performance numbers after the break.
All right. Stay tuned.
We'll be right back. Okay, so the big reveal. Did they actually hit that 100 gigabits per second?
I'm on the edge of my seat here.
Well, not quite, but remember, we're in a virtualized environment here. There's always going to be a bit more complexity.
Right. Makes sense.
So after all the optimizations, he managed to get 55 gigabits per second for VM to VM communication on the same host.
55 gigabits per second. That's still really impressive.
Oh yeah, definitely more than 5 times faster than when they started.
And what about between VMs on different hosts?
For that, they reached 45 gigabits per second.
Wow, so even though he didn't hit the full 100 gigabits, it's still a huge improvement.
Exactly. And it shows that even in a virtualized environment, you can still get some pretty amazing performance with the right tuning.
This deep dive is really showing just how important optimization is.
Yeah, it's not just about having the fastest hardware, it's about knowing how to make everything work together efficiently.
So if someone is thinking about setting up 100 GBE in Proxmox, what are the most important things they need to know?
Well, I would say the absolute must-have is multi-queue networking.
Yeah, that seemed to make a big difference in this case study.
Definitely, you need to make sure your NIC and drivers support it and that it's configured correctly in Proxmox.
Okay, so multi-queue networking. What else?
Resource management is also really important, especially the CPU and memory.
Right, because those are the big bottlenecks.
Exactly. If you can try to assign your VMs to a single NUMA node to reduce those memory access delays.
And what about CPU pinning?
Yeah, that can also help by tying specific processes to specific cores.
So basically, you need to have a good understanding of how your system is laid out.
Right. The more fine-grained control you have, the better.
And what's the verdict on SR-IOV?
It really depends on your needs. If you absolutely need the best possible performance and you're willing to give up some flexibility, then SR-IOV might be a good option.
But it's not for everyone.
Right. It can make things like live migration more difficult.
Okay, so multi-queue networking, resource management, and maybe SR-IOV, anything else?
I would say keep a close eye on your CPU utilization because a 100 GBE network can really put a strain on the processor.
That makes sense.
So look for a CPU with high core count and clock speeds.
It sounds like taming the 100 GBE beast in Proxmox is not an easy task,
It's definitely not a beginner-level project.
but the rewards can be pretty amazing.
Yeah, if you need that kind of speed and you're willing to put in the effort, it's definitely achievable.
Now, this deep dive has been focused on Proxmox, but I'm assuming a lot of these principles apply to other virtualization platforms too.
Absolutely. The fundamentals of networking are the same regardless of the platform.
So even if you're not using Proxmox, you can still learn a lot from this.
Definitely like the importance of multi-queue networking and optimizing your resource allocation.
I think it's really interesting how the author of this case study methodically went through each bottleneck and found ways to improve it.
Yeah, it shows that with a little bit of knowledge and effort, you can really push the limits of what's possible.
So what's the takeaway for our listeners? Is it worth it to try and get these kinds of speeds in a virtualized environment?
I think it depends on your specific needs and priorities. For some people, the flexibility and cost effectiveness of virtualization might be more important than raw performance.
But for others, speed might be the most important factor.
Right, it's a trade-off.
And sometimes you just have to try it out and see what works best for you.
Exactly. There's no one-size-fits-all answer.
Well, hopefully this deep dive has given our listeners a better understanding of what's involved in setting up a 100 GBE network in Proxmox.
And even if you're not aiming for 100 GBE, a lot of the principles we discussed can still help you optimize your network performance.
So no matter what your speed goals are, there's always something to learn.
Definitely. And the world of networking is constantly evolving, so there will always be new challenges and opportunities.
Well, that's a great note to end on.
Yeah, keep experimenting, keep learning, and keep those networks humming.
Thanks for joining us for this deep dive into 100 GBE in Proxmox.
Until next time.
So, we've been talking about 100 gigabit Ethernet is like this, incredible speed, this ultimate goal.
It's definitely a big step forward.
But it got me thinking, what comes next? Is 100 GBE the end game, or is it just like a stepping stone to even faster networks?
Oh, it's definitely a stepping stone. The networking world is always moving forward. 200 GBE and 400 GBE are already starting to show up, and in some places like data centers and labs, those speeds are becoming more and more common.
So let's say we do this deep dive again in a few years.
Yeah.
What do you think will be different? What kind of challenges will we be talking about?
Well, I think for one thing, we'll probably be talking about even more powerful CPUs, maybe even systems with multiple CPUs to handle those massive data rates.
And more power means more heat, so cooling becomes even more important.
Oh, yeah, for sure. We might even be talking about liquid cooling for network cards as like a standard thing.
And what about the software side of things? Do you think Proxmox, or whatever the popular virtualization platform is, will be able to keep up?
That's a really good question. It's going to be a constant race between what the hardware can do and how well the software can be optimized.
Yeah, the virtualization layer itself will need to become even more efficient to handle those speeds without adding too much overhead.
Right. It's going to be interesting to see how things develop.
It's pretty mind-boggling to think about this constant drive for faster and more powerful networks.
It is, and that's what makes it so exciting. There's always a new challenge to tackle, a new frontier to explore.
So for our listeners out there, as you're planning your own network setups, keep in mind that whatever speed you're aiming for today, there's always something faster on the horizon.
That's right. And all the knowledge you gain, the optimization techniques you learn, those will be valuable as you move to those faster networks.
Well said. I think that's a great point to wrap up on. So we hope this deep dive into the world of 100 GBE and Proxmox has been helpful as you plan your own networking adventures.
Absolutely. And remember, even if you're not going for 100 GBE, a lot of things we've talked about, like multiqueue, NUMA awareness, and careful resource allocation, can still make a big difference in your network performance.
That's right. No matter what your speed goals are, there's always room for improvement.
Exactly. And the world of networking is always changing, so there's always something new to learn.
So keep experimenting, keep learning, and keep those networks humming.
Until next time, happy networking.
See ya.